So yesterday we kind of recapped section 6.2, the solving equations. So what I really want to review is section 6.1, which was the inverses. So remember when you're dealing with the inverses, you had to look at which quadrants they could exist in. So it was kind of like the solving equations, however, we were limited on our answer. With each inverse function, you only had two quadrants that you dealt with. When we were looking at sine inverse, its reciprocal, cosecant inverse, and tangent inverse. Those three could be in quadrant 1 or quadrant 4. When we had cosine inverse, its reciprocal secant inverse, or cotangent inverse, those three could be in quadrants 1 or 2. So remember, we had to pick two consecutive quadrants, either 1 and 2 or 1 and 4, one where it was positive and one where it was negative.
And what was the reasoning why it couldn't be in quadrant 3?
Because, okay, so for it to have an inverse, it has to be 1-to-1, it has to pass the horizontal line test. That's why we can't take all 4 quadrants. We prefer to not do quadrant 3 because when you think about your graph, you want to just be able to graph like one complete piece. You don't want to graph the piece in quadrant 1, nothing, and then the piece in quadrant 3. We want a consecutive section of the graph. So, for example, we had to do this only when the original problem had an inverse. So if I said y equals sine inverse of, let's say, negative radical 2 over 2. So as soon as I see the sine inverse in my problem, then I know that I'm only dealing with half the quadrants. Sine inverse could be quadrant 1 or 4. Because this was a negative, that meant we were going to be in quadrant 4. So the question is really just, when does sine equal radical 2 over 2?
45.
45 degrees, so that's your reference angle. So then 45 degrees in quadrant 4, so 360 minus 45 is 350. So when you have an inverse, you get only one answer. If I said y equals arc secant of negative 2 radical 3 over 3. Okay, so arc secant is the same as saying like secant inverse, just a couple different notations that we can use. When I see secant, I'm thinking secant is like cosine, so that could be quadrant 1 or 2. Which quadrant would this be?
2.
So I'm asking, when does secant equal 2 radical 3 over 3? Or if that's harder for you to think about, secant is the reciprocal of cosine. So this is like saying, when does cosine equal, if I did the reciprocal of this, you got the radical off the bottom, it's negative radical 3 over 2. So if it's easier for you to think in sines, cosines, and tangents, you can always do that reciprocal. So when is cosine radical 3 over 2?
Just 60?
That's when sine is from 303. So 30. And so then 30 degrees in quadrant 2, 180 minus 30 is
150.
okay. So y equals cotangent inverse of negative 4. Alright, do we, when I see cotangent inverse, which quadrant can it be in? Since it's negative, it's quadrant 2. Do we know when cotangent is negative 4? No, so we're going to have to use our calculator. What this means is that tangent is negative 1/4 because we don't have a cotangent inverse, but we talk about it in terms of tangent. What I told you on these is not to type in the negatives on your calculator. So on the calculator, I want you to do tangent inverse of positive 1/4. Let's make sure we're in degree mode. So tangent inverse of positive 1/4. So I get 14.04 degrees. That's our reference angle. So then we need an angle in quadrant 2. So how would you put that in quadrant 2? 180 minus that. So we get 165.96 degrees. Are these okay? The last type of problem I want to review from this section is what if I gave you so what we know is the answer to an inverse is an angle. So this represents some angle. On these, I would say give me the exact value, so not something from the calculator, so we have to work it out. What we need to find is cosine of whatever that angle is. Do you guys remember what we did on these?
We'll triangle.
So sine inverse could be quadrants 1 or 4. But because the 2/5 is positive, I know I'm in quadrant 1. So I'm going to draw a triangle in quadrant 1. Sine is opposite over hypotenuse. So now we have to find our missing side.
How do you know what, where I know the Pythagorean Theorem, but how do you know where to apply them?
SOHCAHTOA, sine is opposite over hypotenuse. So from this angle, the opposite side is your 2. The hypotenuse is
So your opposite side is A in the Pythagorean Theorem?
It doesn't really matter if it's A or B, as long as your hypotenuse has to be your
It's C, okay.
Since we're in the first quadrant, this side is positive, so we get a positive radical 21. So then I want cosine from this angle. So if you think about SOHCAHTOA, cosine is adjacent over hypotenuse. So radical 21 over 5.
Did we take a test over this already, or was that a quiz?
Oh yeah, I don't think we've done any.
Yeah, I don't think we've done any.
No, this was just like last Monday. That we did this. I mean, we've done
I thought we-
SOHCAHTOA and stuff before.
Why do I